Assalamualaikum and hi everyone. Now we're going to learn on analysis of functions. The learning outcomes of today's lesson is to determine the interval on which the function is increasing or decreasing, and after that we are going to determine the extremum point, and next we are going to determine the interval on which the function is concave up or concave down, and after that determine the inflection point. Now we look into the increasing and decreasing function. The figure shows a graph with interval between 0 and 2. This is interval between 0 and 2. And 4 to 8, the function is increased. Look at here, 0 to 2 and 4 to 8, the function is increased. And if we draw a tangent line in that interval, it has a positive slope. While in between 2 to 4, the function, if you look at here, it is decreased. And if we draw the tangent line in that interval, it has a negative slope. Alright, so we write here, okay, the f is increasing on interval 0 to 2 and also increase on the interval 4 to 8, and the graph is decreased on the interval 2 to 4, and it is linear on interval x greater than 8 or 8 to positive infinity. Now we look at the increasing, decreasing and linear test. Let f be differentiable on open interval AB. The first one, if f prime x greater than 0 on AB, then f is increasing on AB. If f prime x less than 0 on AB, then f is decreasing on AB. And lastly, if f prime x equal to 0 on AB, then f is linear on AB. Now we look at the first example. We want to determine the interval where the function is increasing on and decreasing. For function fx is equal to x plus 2 multiplied with x minus 1 squared. Okay, we are going to find the interval where the function is increased and decreased. So first we find the f prime x. If you look at this one, fx, it is a product between x plus 2 and x minus 1 squared. So therefore we need to use the product rule to get the f prime x, right? After we u, v, u prime and v prime, alright? So after we simplify, we get the f prime x as 3x minus 1, x plus 1. So here, if from the factorization here, we get the important points, x equal to 1, x is equal to negative 1. So it is actually, if we calculate f prime x is equal to 0, so we get, if we make it equal to 0 here, okay, 3x minus 1, x plus 1 equal to 0, therefore we get x is equal to 1, x is equal to negative 1. So that is how we get the point, x is equal to 1, x is equal to negative 1. Next, we build the sign analysis table for f prime x. Okay, how are we going to draw this one? So first of all, based on the important points, we are going to draw the line. So we have point x negative 1, x is equal to 1. Okay, we arrange it in sequence, alright? So this area on the left of x less than 1, it is, we call it x less than negative 1. So in between here, this is area negative 1, x between negative 1 to 1. And this area is x greater than 1. Alright, now we choose the first factor from the where we simplify the f prime x. So we have x minus 1, the first factor. If we look at here, x less than 1, so we choose any value x less than 1. For example, we pick up x negative 2. So negative 2 minus 1, it is negative 3. So therefore, it will be negative here. Okay. And similarly here, we pick up value x between negative 1 to 1. We pick up 0, for example. So 0 minus 1, we get negative 1. So therefore, it is negative here. For this part, alright, x greater than 1. So pick up x is equal to 3. So 3 minus 1, you get 2. Therefore, it is positive. Okay, in similar manner, we take the second factorization, x plus 1 here. Okay, in similar manner, we test the value here. Let's say x negative 2 plus 1 is negative 1. So we choose any value between -1 to 1. Let's say we pick up 0, 0 plus 1, you get 1, positive. And this one, x greater than 1, we choose x is equal to 2, for example. Okay, we get it as 2 plus 1, we get 3. So that is why we get positive here. So that is how we get the plus minus sign for x minus 1 and x plus 1. Now we find the f prime x. Okay, if f prime x, if you look at here, it is the multiplication between these two functions. So therefore, we multiply the two sign. Okay, negative and negative, we get positive. Negative and positive, we get negative. Positive and positive, we get positive. So if you draw a line here, f prime x, we know the slope will be positive. Alright, so the slope is like that. We draw the line something like this. It is a slope positive because it is greater than 0. So this one we get slope negative. Alright, so this is a line where the slope is negative. And here also we have slope positive. Alright, positive. So this is a line that represents the slope positive. So therefore, if you look at here, okay, so we look at here, the graph is increase here, decrease here, and increase here, right? So from here, okay, so we can write here, since it is increased for x less than -1 and x greater than 1, so f is increasing from negative infinite to -1, 1 to positive infinite. Okay, we get from here. So this is the increasing part. Okay, so x less than 1. X less than 1 means negative infinite to -1. Okay, and then it is also increased on the interval x greater than 1. So x greater than 1 means 1 to positive infinite. And similarly, if you look at the graph here, f is decreased in the interval -1 to 1. Alright, so therefore f is decreasing on -1 to 1. That is how we get the interval of increasing and decreasing. Okay, now we look into at the extremum points. Okay, from the graph, we can see that at x is equal to c, fx is maximum compared to other points nearby, right? And similarly, at x is equal to d, fx is minimum. The function is minimum if we compare to other points nearby. So therefore, since at x is equal to c, the function is maximum compared to the points nearby. So x is equal to c is a relative maximum. Okay, when x is equal to c, f has relative maximum. And similarly here, at x is equal to d, we can see that f is minimum compared to other points nearby. So at x is equal to d, f has relative minimum. Now we look at the definition of critical number. A critical number of a function f is a number c in the domain of S such that f prime c is equal to 0 or f is not differentiable at c. Or we write it, if f prime c is equal to 0, the critical point CFC is called a stationary point of f. Next, we try to find the critical number of a function fx is equal to x squared minus 4x plus c. So if you look at here, if you want to find the critical number, we need to find f prime x, since f prime c is equal to 0. So f prime x, we differentiate, we get 2x minus 4. We make it equal to 0. So we get x is equal to 2. So therefore, the critical number for this function is x equal to 2. Now we look at on the first derivative. Let's see is the critical number. If f prime changes from positive to negative at c, then f has a relative maximum at c. If we draw a sign table analysis for f prime x, okay, with f prime is changes from positive to negative, okay, for x less than c, f prime x is positive, for x greater than c, f prime x is negative. So if we draw the lines, this is positive, slope positive or increase, and this is slope negative, okay, decrease part. Alright, so if we join the two points here, the two lines here, so we can see that the graph is maximum at x is equal to c compared to points nearby. Okay, so the f is maximum at x is equal to c. So therefore we said that at x is equal to c, f has a relative maximum at c. Okay, now we still proceed with the first derivative test, but with different cases. Okay, if f prime changes from negative to positive at c, then f has a relative minimum at c. Okay, now we also look at the table sign indices of f prime x, where it changes from negative to positive. For x less than c, f prime x is negative. For f prime x greater than c, f prime x is positive. So if you draw the line negative, this is slope negative or decreasing part, and this is the slope positive. If we join the two lines, alright, we can see that f is minimum compared to other points nearby. Alright, so f is minimum at x is equal to c. So therefore, we said that f has a relative minimum at c. Now we look at the first derivative test for the third case, okay, where f prime does not change in sign at c, therefore f has no relative maximum at c. So let's say we have this one, we can see the fx, the sign is not changed here. Alright, at x is equal to c, the left x less than c, it is negative, and x greater than c, it is also negative. So if we draw the slope, okay, the line, both has slope negative or decreasing part. If we can see that if we join the two graphs, we cannot get any extremum point. Yeah? So therefore, there is no relative extremum at x is equal to c. Similarly here, if we have the sign plus and plus, okay, x less than c is plus, x greater than c is plus. So if we draw the lines, we get positive and positive the slope. Alright, if we join the two lines, okay, we don't get any extremum point. So therefore, f has no relative maximum at x is equal to c if the f prime does not change in sign at c.